You must have noticed that electrical appliances heat up while they work. Take an example of a mobile charger. The adapter becomes hot after some time, doesn't it? Similarly, you might feel the heat on your hand if you touch the light bulb immediately after switching it off. But why do the electrical appliances heat up? Yes, it's because of electric current. Electric current heats up the objects through which it flows. Here, the electric current heats up the adapter and the light bulb. This effect generated by the current is called the heating effect of the electric current. But is heating of the appliance due to electric current always a bad thing? Not necessarily. There are so many common electrical appliances that work because the electric current heats up some material. Electric iron, electric heaters, light bulbs are just a few of these appliances. Let's talk about the light bulb in detail. Do you know how it gives off light? You must have seen this torch bulb in your previous videos. Let's use this bulb instead to understand the working. We know that this small metal thing connected to the ends of the two thin rods is the filament of the bulb. Do you know what this filament is made up of? The filament is made up of tungsten. What is tungsten? It's a metal and a conductor of electricity. However, it's not an efficient conductor compared to, say, copper. What does that imply? It implies that tungsten gives more resistance to the flow of electric current than copper. The copper wire also offers some resistance to the flow of electric current, but it's very less compared to the resistance offered by tungsten. So what happens when we connect it with a battery? Let me explain it in detail. We use the term electrical energy instead of electric current. In fact, we have seen in the past that electric current is nothing but the flow of energy. When the electric energy flows through the filament, it converts some of this energy into light energy and some into heat energy. Yes, there is conversion of energy taking place. Light energy is nothing but the light that we get from the bulb. Most of the electrical energy is converted into heat energy, while some is converted into light. So the filament heats up and glows. This heat radiates from tungsten into the surrounding and heats up the glass chamber. What if tungsten was a very efficient conductor of electricity? Well, then it will result in a short circuit. The energy from one terminal of the cell would have flown straight to the other terminal with very little being converted into the other forms of energy. It is similar to connecting the two terminals of the cell with a wire. Never connect the two terminals like that. Another advantage of tungsten is that it can withstand very high temperatures. It can withstand temperatures up to 3400 degrees Celsius. And what about copper? Copper will melt at a temperature anything beyond 1100 degrees Celsius. So this is how the light bulb works. But this was just one of the applications of heating effect of electric current. We will see more of them in our next video.